Hello everyone. Finally we are live here, right? Okay, so guys, actually we were facing some technical issues, so that is why it got delayed this session. इसलिए हम आ नहीं पाए यहाँ पे session में. So let me check who all are here. Okay. 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 So a very good afternoon, good evening, everybody is here. Welcome to the session. Okay. So first of all, let me tell you who I am here. So my name is Pooja Rai and I will be taking your session, and this is going to be this entire session is going to be a revision session, kind of concept based question, and some concepts also I will be solving here. Okay. So again, very warm welcome, and let me please let me know guys if I am visible and audible to everybody. Okay. Okay, so I could see here that I am audible to everyone. Okay, so let me tell you everyone that first of all welcome to the session, and this session is going to be a very fantastic, and पूरे सेशन में हम क्या करने वाले हैं, हम पूरे सेशन में कॉन्सेप्ट्स को पढ़ने वाले हैं श्रेयस सर के साथ. ठीक है, श्रेयस सर के साथ हम क्या करने वाले हैं, कॉन्सेप्ट्स को पढ़ने वाले हैं. ठीक है, तो let's start our session, and let me tell you before the session, like before proceeding this session, what we are going to tell you, like what we are going to learn here basically. So इस पूरे सेशन में we are going to learn that we'll take some question. Okay, the very first we'll be taking some questions, and based on this question we will be taking some concepts here. Okay, we will be taking some concepts here. Okay, so I'm requesting you to everybody जाकर अपने फ्रेंड्स को बुलाओ, जो भी है कि लाइव स्ट्रीम शुरू हो गया है, कॉन्सेप्ट्स पढ़ने मिलेंगे, कुछ क्वेश्चंस करने मिलेंगे, एंड दिस क्वेश्चंस आर दिस इज वेरी रिपीटेड क्वेश्चन, और इस सारे कॉन्सेप्ट पे बहुत सारे क्वेश्चंस आते हैं, ओके. So is everybody ready for the session? That's very nice. So let's start the session everyone here. So the very first Shreyas sir will be coming here, and Shreyas sir आपको क्या कराएंगे, कुछ questions कराएंगे. ठीक है, वो questions को क्या करने वाले हैं, उस questions पे अगर आपको कोई भी डाउट हो, सिंगल सा भी डाउट हो, तो आपने क्या करना है, उस क्वेश्चन से रिलेटेड क्वेरीज को क्या करना है, पोस्ट करना है चैट बॉक्स में, सो आई कैन नो द एग्जैक्टली कि तुम्हें कहाँ प्रॉब्लम आ रही है, एंड बेस्ड ऑन दैट क्वेरीज आई विल बी टेकिंग ऑल द concepts here. Okay, so let's begin.
Batch wiki, it's all in English. Yep. So now the thing is, when you leave that charge, what happens, it will try to fall down. Why will it try to slide down or fall down? Because of gravity. But there is a problem, there is a charge over here. What will that charge do? It will try to repel it. So what will happen, that charge will come, it will attain some equilibrium somewhere. The gravity is pulling it down, the electrostatic force is repelling it up. So it will maintain some equilibrium. Now let's say you move that charge a little bit far away, you move it. What will happen? Gravity is still acting. Because you are separating the distance, you are increasing the distance. What will happen? You will see the force of electrostatic will reduce. The moment the electrostatic force will reduce, understand the repulsion has reduced, you will see the gravity will pull it back. So as soon as it moves down, then the repulsion will become strong. As soon as the repulsion becomes strong, it will push it back. Again the repulsion will become weak, so it will again come back. So it will basically oscillate. It will basically oscillate. Hence the question is, find the time period or frequency of oscillation. That's the question. Are you ready to do this? I hope you understood what the question explains or describes. So there is a charge at equilibrium, you push it here or there, it starts oscillating because of the variations in the electrostatic force, and that's because of the variation in the distance between them. Okay, let's do this. I think the first thing we need to do is figure out the equilibrium distance. Without that, I don't think we can proceed ahead. So let's think about it. At equilibrium, what and all is going to happen? So number one, okay, first you have the mg sine theta force here. You obviously have the normal and mg cos over here, but let's not worry about it. There is one more force, and that is k q divided by the equilibrium distance is given to be x naught. It's clearly mentioned. So k q1 q2 by r square. These are the forces, and this is at equilibrium. So what am I going to write for this mass? Okay, for this mass over here, m, my mg sine theta, okay, my mg sine theta will be k q divided by x naught square. This is what I got. Okay, I'll keep this besides. I won't need this for now, maybe later on. Now what we are going to do is, we are going to move this charge slightly. The idea for moving it slightly is because whenever you have to find time period or frequency of oscillation, either find the equivalent spring constant or you find the equivalent system which will convert it into a spring mass system, or somehow show that the force is proportional to x. Now there are no springs here, so the best approach would be to somehow show that the force acting on it is proportional to x. I hope this point is clear. Okay, these are very good questions, guys. These are going to boost your rank in the upcoming JEE Mains examination. So focus, and also let me know if you are understanding, and so that I know you guys are alive as well. Okay, now let's say I increase the distance. I increase the distance by a small amount x. So this was x naught. I change the distance by x. So x is nothing but the disturbance, the extra displacement, which I have done. Now, what are the new forces acting on that charge? The new forces acting on that charge are, well, mg sine theta will still be there, so let's not worry about it so much. So mg sine theta is there, mg cos theta is also going to be there, and the normal force is also going to be there. But normal and mg cos are perpendicular in that direction, so we don't have to really worry about it. Okay, no, this is not advanced question, this is mains question only. Okay, these are all mains questions. Now understand, there will be a new electric force. What will be that new electric force? It will be k q, but this time it will be x naught plus x whole square, because that's the separation, x naught plus x whole square. If everybody is understanding this, then let's go ahead. Now think about it. You have moved it there. So if you are moving it upwards, what will be the restoring force to pull it back? So what is that restoring force? Let's start from here. The restoring force will be mg sine theta, that's down, minus k q divided by x naught plus x whole square. The restoring force means the force which tries to bring it to equilibrium. So it is trying to mg sine theta minus because it's opposite to the displacement, or opposite to mg sine theta. Yep. Okay. So Sri Dharma Agarwal, I started at the beginning saying that, there is a charge over there, it is at equilibrium. Why is it at equilibrium? Because mg sine theta is being balanced by electrostatic force. Now what is happening is, if you disturb it here or there, electrostatic force will change. That causes the restoring force. That's all. Okay, so what has happened over here is initially it was at x naught distance. I moved it further by x. So the moment I move it further, what will happen? The repulsion will reduce. So this is that new value of the electrostatic force. This is mg cos, by the way. This is mg cos theta, which I don't care. This is the normal force, that also I don't care. So mg sin theta is the same, only the electrostatic force has decreased. Because the upward force has decreased, the net force is downwards. It's trying to restore it back. I hope this is clear. Is that clear, everyone? Sridharma, Nankit, and all the others out there? So guys, this is not an advanced question, let me tell you that. You have to do it in mains only if you want to get a good rank. Now, the things are simple. I'll tell you what you need to do. It's all maths. So guys, if you are strong at maths, you will get it. So see, the idea is to somehow show it proportional to x, right? So I will have to use binomial to bring this guy on the top. Let's bring this guy on the top because this x is going to be really small. So before doing that, here is what I'm going to do. So f restoring will be mg sin theta minus k q divided by, bring x naught outside because I want binomial form. Remember binomial approximation? 1 plus a small number raised to n. 1 plus a small number raised to n. So I want that small number. So bring that x naught outside. So it will look like this. X naught square into 1 plus x by x naught whole square. So even if you bring it inside, you will see x naught will cancel here and x naught square will come inside. Yep. So you can take that power 2 outside then. I hope this is fine. Now, the next step will be mg sin theta minus k q divided by x naught square. Okay, the whole thing into 1 plus x by x naught whole raised to minus 2. Now guys, don't you see this number is very small because x is very small. X naught is a good distance. X is a small disturbance which it is undergoing. So this is a very small number. So let us use binomial approximation and see what do we get. We will get mg sin theta minus k q divided by x naught square and 1 plus nx. So 1 plus n is minus 2, x is x by x naught. Now you can very easily see mg sin theta and k q by x naught square. Mg sin theta and k q by x naught square, both of them will cancel out each other. They will cancel out each other and hence what will I get? I'll just get, oh, that mg sin theta and this has gone, minus and minus is plus, so 2 k q x divided by x naught square into x naught, which is x naught cube. That's your restoring force. Now I think you got the hint from here. I think you got the hint. How do I know that binomial is going to be applied? Because Ankit, you have to solve many problems for that. Whenever you see something in the downstairs, in denominator, and you know, eventually you have to bring it on the top. Why do I have to bring it on the top? Because force has to be proportional to x. Because that's how SHM works. So that's why I realized, oh, I need to use binomial because there is some addition subtraction over here and it's in the downstairs. I bring it on the top and there has to be some kind of expansion. That's why. Yep. This is nothing but your spring constant equivalent K. This is your equivalent K. F is something x, Kx. This is your equivalent K. So that's it. So all you need to do is this is your equivalent spring constant. That's all. So now all you need to do is, let me erase this, it's no longer needed. So my time period will be 2 pi under root m by k. K is this value, so that's 2k q by x naught cube, but I do not want this m. Okay, so you can even get rid of that m from here. Look at this m. What is that m equal to? Well, that's k q divided by g sine theta, and you have x naught square, g sine theta and x naught square, and these remaining terms as it is. That's 2kqq, and you have x naught cube. Okay, great. So the final answer of time period will be 2 pi under root kqqq gone, x naught square gone. So x naught by g sine theta, that's the time period. Frequency will be 1 by the time period. That's it. Oh, I think that 2 was also there. Yes, that 2. Yep, the 2 will also be there. Yep. Okay, is that clear? Everybody understood? This was one very good problem which I feel is very, very important you guys should solve. It doesn't matter whether I framed it on my own or I found it in some book or I found it in some test paper, doesn't matter. The point is that you should know how to solve this question because it has so many concepts. Free body diagram, Newton's laws, electrostatics, SHM, all of that. So it's a very good question. So why we should not minus mg sine theta from the electrostatic force? You can do that, Karthi, but what we did is we found the restoring force. See, if I displace it here, restoring force is this way. So all the forces in this direction will be positive, all the forces in this direction will be negative. That's why I have written mg sine minus the electrostatic force. No, this question cannot come for NEET, obviously. Okay, so we got the frequency. Let's go to the next question. Now, this kind of question probably can come in NEET. I don't know, but this is definitely a good JEE mains question. Let's see how many of you can get this. Okay, welcome everyone. So Karthikeyan K, I will definitely answer your question. Just post up all your comments after the video ends or send me your message on my Instagram handle out there. I'll definitely reply to you. Okay, okay, cool. Let's do this question. So look at this. This is a pyramid. Okay, it has 4 faces. All of them are equilateral triangle of side A. So this 4 faces, okay, are of side A, and I think this diagram is slightly wrong. My bad, guys. This diagram should not have been there. Okay, because it has 4 faces. This had 5 faces. I'll just draw it for you. Okay, I'll just draw it for you. Don't worry. Okay, so what you have is a pyramid something like this. Okay, and yeah, this is the hidden side. That's it. So 4 faces, 1, 2, behind and bottom. These are the 4 faces. And what you have done, you have placed a charge q. Where have you placed a charge q? At the center of one of the faces. Let's say at the bottom face, you have a charge. Okay, so at the bottom face, you have a charge placed. The question is, what's the flux which emerges out of any one of those 3 faces? What's the flux which is going to come out because of from any one of the faces? This is not supposed to be field, this is supposed to be flux. Okay, how are we going to do this? Any idea? Any idea? Think about it. Think about it. What are we going to do? Okay, yo, solving, says Ankit. I'll give you a hint. The hint is use symmetry. Use symmetry. Do you guys agree that the flux through this face, the flux through this face, the flux through this face, and the flux through this face, out of them, some 3 faces will have the same flux? Yes, some 3 faces. Yeah, think about it this way, that except for the bottom face, okay, just forget the bottom face, this face, the one here, the one there, and the one behind, all 3 of them by symmetry will have the same flux, except for the bottom one, because for the bottom one the charge is on that face. Remember, the charge is on that face, but this and this, they all will have the same flux, correct? Now, here is the thing. How about drawing one more pyramid below it? Yep, let's draw one more pyramid and see what do we get. Okay, so we have one more pyramid out here somewhere like this. Okay, so this is one more pyramid that we got. Okay, so now I hope you can see there are some more faces out here. Okay, Now you can see there is one face there, there is one face here and one face here. Now do you see there are totally 6 faces? 1, 2, 3, 4, okay, 5 and 6. 6 faces, and all 6 faces have symmetry. That means they will have the same flux. Think about it. Think about it. You don't need the angle or anything. Yes, all the 6 faces, 1, 2, 3 on the top, 1, 2, 3 at the bottom. The charge is exactly at the center. So the thing is, the net flux is going to be Q by epsilon naught. But this net flux is going to pass through 6 faces equally. That means the flux through any one such face will be Q by 6 epsilon naught. That's the answer. Yes, Mala Mohan, these questions are going to come in JEE Mains, these kind of questions. They have come previously, they have come this year, they have come before this also. So that's why we call it rank booster series.
Okay, so everybody's in the previous question we were using that flux. हम flux पढ़ रहे थे, ठीक है. अब हमें यहाँ पे पढ़ना क्या है कि flux का concept पढ़ना है कि flux exactly होता क्या है, ठीक है. फ्लक्स आएगा तभी तो हम क्वेश्चन सॉल्व कर पाएंगे. और इलेक्ट्रोस्टैटिक्स लाइक इलेक्ट्रिक फ्लक्स पे बहुत सारे क्वेश्चंस आते हैं, बहुत सारे क्वेश्चंस पे बेस्ड नीट पे भी आते हैं, बोर्ड एग्जाम में भी आते हैं. सो लेट्स लर्न अबाउट इट. ओके, सो okay, so as can see, first of all we have to know what is flux. Okay, what is electric flux. Okay, तो सबसे पहले मैं ये बताती हूँ कि electric flux होता क्या है. So electric flux होता है the total number of electric field line passing given area in unit of time defined as a electric flux. Okay, that's very simple, like it is the definition, but how we will get to know exactly इसका meaning क्या है. Okay, how we will get to know कि exactly flux कहता क्या है और flux का concept क्या होता है. ठीक है, definition तो we understood, right? But the total number of electric field line. So can you see here the total number of electric field lines? So this is one, surface and the number of line which is passing through it. Okay, which is passing through it, that event defined as a electric flux. Okay, that event defined as a electric flux. So the basically electric flux we are symbolizing with the flux, I mean this phi sign. Okay, as in the electric flux which is passing through this surface. Okay, can you see here this, this is the electric field line and this is the area. Okay, so in between this it is making an angle, right? It is making an angle. Okay, so what does mean it basically? What does mean it? From here only we got the formula of the flux. Okay, that is phi E dot E. Since this is dot product, since this is dot product, so when we will be removing the dot, what we will be getting? Will be getting the cos theta. Correct? Will be getting the cos theta. Right, everyone? So that means, what is that cos theta? Okay, so Tanay Rai is saying that किसको पढ़ा रही हो मैम? Okay, आप सबको ही पढ़ा रही हूँ तनय, because it is the concept based, आपका जो questions हो गया है, ठीक है, उस questions पे क्या करना है, हमें कुछ electrostatics के concepts आते हैं, so that concept should be clear, right? इसीलिए तनय क्या हो रहा है, ये concepts चल रहे हैं, ठीक है? Okay, so this cos theta between the surface and electric field line का, angle. So that's what we call the electric flux. And the same concept हमने क्या किया, हमने अपने क्या किया previous question में हमने पढ़ा, ठीक है. So electric flux, the concept, it is very very important, and we need to learn and we need to understand exactly, you know, कि flux कहाँ पे use करना है, या फिर flux का concept जैसे ही question में आता है तो वहाँ पे हमको क्या करना है, उसे apply करके सारे question उसके calculation या फिर उसके answers निकालने हैं. Okay, so this was about the electric flux. Now let's learn the few more, you know, the doubts from this sir, and based on this we'll learn bit more concepts as well. Okay.
So please understand, lot of institutes fool students by giving them very simple questions, and then students think, oh, these are the kind of questions which are going to come, but they haven't never really seen the kind of questions which actually come in the JEE Mains examination. So that's why electromagnetism with PYQ and the most probable questions. So hence the answer is Q by 6 epsilon naught. Okay, cool. So that's how it is. So Q by 6 epsilon naught. If you guys have understood this, if you loved the answer, please let me know. By the way, again, this diagram shouldn't have been there. Let me just remove this, and this should have been flux, guys. Let me just change it. Yep. So the flux here and here. Okay. So let's change it. Okay, cool. Okay, let's get going. Arya, well, maybe someday, definitely I'll do something on catalysis channel, definitely, Arya. Okay, now here is the next question. Beautiful question again. Capacitors are there, and the question is find the amount of charge which flows once you close the switch. These options are not so important because anyways you have to get to the answer. So let's just remove these options. So in this system, when you close the switch, what is going to happen? Okay, let's do this step by step. First, let's do when the switch is open. Now when the switch is open, observe what is going to happen. This 2 microfarad and the 3 microfarad will have a potential difference of 10 volts. Yes, there is a potential difference of 10 volt here. Okay, this is 0 volt because that branch and this branch both are in parallel with this 10 volt. So it's as good as there is nothing connecting between A and B because the switch is right now open. Now this is obviously 2 microfarad, this is 3 microfarad. So first of all, figure out what is the effective capacitance. It is C1 C2 by C1 plus C2, which is 6 by 5 microfarad. Now you can find out the charge on each one of them because in series the charges are same. So it is C, okay, C into V, which is 10. So that's going to be 10 by 5, 2, 6 2s are 12 microcoulomb. That means this will have plus 12, this will have minus 12, this will have plus 12, this will have minus 12. So these are the charges which will be there on the capacitors. Okay, keep this aside. Now I don't need this anymore. Now let's look at the situation after closing the switch. So S is now closed. The moment you close it, what is going to happen? This capacitor and this capacitor will be in parallel because these 2 points will be at the same potential and these 2 points are also at the same potential. So this and this in parallel, this and this also in parallel. So the effective diagram will be something like this. Okay, it's a capacitor, something like this. Okay, and you can probably think of it this way. Something like this. These two in parallel, these two in parallel, and their combination is in series. Now 2 and 3 are in parallel, guys. This is 2, this is 3, this is 3, this is 2. So this is as good as saying this is 5 because in parallel the capacitances will add. So this is also 5. This is 5, this is also 5. Now each of them is connected, or rather both of them together is connected across 10 volts. This is connected across 10 volts. Okay, now I know what to do. First find the C effective. C effective will be obviously 5 into 5 divided by 5 plus 5. That's going to be 5 divided by 2. 5 5s are 25, and yep, that's what you're going to get. Cool. Now, what we are going to do next is that find the charge on each one of them. Well, the charge will be, the new charge will be C into V. That's going to be 25 microcoulomb. That's going to be 25 microcoulomb. So 25 will be there on both the capacitors. Why are we doing all this? Without doing all of this, you cannot get to the answer. Let me tell you that. Okay. Now, here is the thing. Hi and bye. Sorry, boss. We cannot create a channel right now, but don't spam, okay? Or else you will again get blocked. Now, here is the thing. 2 and 3 are in parallel, which give effectively 5 microfarad. So if 25 microcoulomb was there on 5 microfarad and 5 microfarad each, when you bring it back into 2 and 3, what will be the charges on 2 and 3 microfarad? Think about it. Think about it. What will be the charge distribution? Because in parallel, the charges get distributed in the Q is CV. Q is equal to CV, guys. Think about it. So what will be the charges on each one of them? Voltage is same. Q is directly proportional to C. So charge, so remember, in parallel, charge is directly proportional to capacitance. So if you have to do that, how will you divide 25 in the ratio of 2:3? Divide 25 in the ratio of 2:3. That means divide it into 2 plus 3 parts, which is 5 parts. Divide it into 5 parts, guys. Divide it into 5 parts. Anytime you want to divide something in some ratio, add those numbers. 2 and 3, right? 2 plus 3 is 5. So divide 25 into 5 parts. Now take 2 parts of those things. That means 5 plus 5, which is 10, and take 3 parts of those 5 parts, which is nothing but 15 microcoulomb. I hope this is clear. I hope this is clear. So that means this capacitance will have 10 microcoulomb and the other capacitance will have 15 microcoulomb. Correcto. Now let's do this properly. I don't need many of these things, so I'm just going to redraw the diagram. Just observe this now. I don't need this. So here is what has happened. This was my capacitor over here. Okay. And this capacitance was 2 microfarad. This capacitance was 3 microfarad, the one on the top. Initially, both of them had plus minus 12 micro plus minus 12 micro. Okay, this is plus minus 12. Understand that? Okay, this is what the charges were initially. Okay, I don't need this anymore. I'm going to remove this. Eventually, what are the charges? Final charges, what are they? Let's write it down. So the final charges are, this is the final charges, 10 microcoulomb and 15 microcoulomb. So 2 will have 10 microcoulomb, 3 will have 15 microcoulomb. So this will be nothing but 10, okay, and because this is 3, this will have 15 microcoulomb. That's what it is. Now you just need to think. Let's just forget all of this. It's no longer needed, guys. Trust me on this. You don't need any of this now. You just need to look at these plates. Just look at these plates and you will get the answer. Trust me on this. Look at that. Look at this plate over here and look at this plate over here. Just look at these 2 plates. And now think, what has happened to the charge? Where has the charge gone? Where has it gone? Where has it not gone? Just think about it. You will get the answer. Here is the logic for doing it. What you need to do is, earlier it was minus 12. Now it is minus 10. Earlier it was negative 12. Now that plate has a charge of minus 10. So it has become less negative. That means what would have happened? plus 2 charge has gone into what? This plate. Plus 2 charge goes into minus 12, makes it minus 10. Is everybody clear till this point? Yes, it has gained some charge. Similarly, look over here. It was plus 12, now it has become plus 15. It was plus 12, now it has become plus 15. So what has happened to this plate? Think about it. What has happened to this plate? It has gained how much charge, guys? How much charge has it gone? How much charge has gone? Obviously, plus 3 charge has gone. So totally, how much charge has gone? Plus 2 and plus 3. Plus 5 microcoulomb charge has gone. Yep, that's the answer. That's how you need to do this. So plus 5 microcoulomb is the final answer. Correct. Okay, and you can see that. Plus 5 microcoulomb from B to A. You can see that. That's all.
Okay, so everybody is here. I'm in a previous previous question में सर ने एक concept लिया. The concept is all about कि हमें क्या करना है, equivalent capacitance लेना है. ठीक है, equivalent capacitance लेना है. But this particular this concept exactly based on some कि combination of capacitor. लेट्स से कि अगर कैपेसिटर को 2 कॉम्बिनेशंस में दे देते हैं, फर्स्ट इन पैरेलल, ओके, फर्स्ट इन पैरेलल कैपेसिटर, ओके, एंड द सेकंड कॉम्बिनेशन व्हिच इज गिवन दैट इज सीरीज वाला, देन हाउ यू विल मैनेज दैट? इफ यू विल नो दैट, देन ओनली यू विल बी एबल टू सॉल्व द क्वेश्चन एक्चुअली. ठीक है, सो देन ओनली यू विल बी एबल टू सॉल्व द क्वेश्चन. Okay, so let me tell you here, in the parallel combination, basically parallel combinations में होता क्या है, two capacitor, they are connected like this. Okay, this is the parallel combination of capacitor. Correct everyone? So parallel combination में capacitor का equivalent capacitor, how you will be finding that? So we have a very simple formula here. If two capacitor which is connected in parallel, so simply no need to do anything, just you have that equivalent capacitor, that is C1 plus C2. Okay, so that we know. And anyone just tell me the queries ki, I mean, it's if you're facing any formula based queries or doubt, you can post in the chat box, so I can clear your doubt here only. Okay, and when we come to the series combination of the capacitor, series combination of the capacitor पे क्या करेंगे? Again, the series combination of capacitor, it looks like this. Okay, this is the circuit, and two capacitor which is connected in series, in series way. So basically, to find equivalent capacitance, what we will be doing here, this is the slight difference that how you will be doing, that is 1 by C equals to 1 by C and equals to 1 by C1 plus 1 by C2. Okay, this is the easiest method, that in the easiest way you can find out the equivalent capacitance, and you can use this concept while solving any problem, any combination, the kind of problem we had, sir solve करा रहे थे. इन सेम प्रॉब्लम में जैसे ही हमें क्या मिलता है, इक्विवेलेंट कैपेसिटेंस का कोई भी कॉम्बिनेशन आ जाता है या फिर कोई भी कॉन्सेप्ट आ जाता है, सो यू जस्ट नीड टू रिमेंबर दैट if the capacitor which is connected in parallel, so what you will be doing, you need to be find the equivalent capacitor, that is C1 plus C2. Okay, come to the series combination, it is 1 by C equals to 1 by C1, 1 by C1 plus 1 by C2, and like that it will go. Okay, so this was about the capacitor. Let's have look the another question, and after that we'll learn the bit more concept. Okay.
Option A. Okay. Chalo. Now after this, most of the questions are normal level. Don't worry, I had taken some really good questions for all of you at the start, so that you guys get really warmed up with some really good questions. So are you guys really heated up? Are you like burning now? Somebody just commented, if this question comes in the NEET exam, they are going to break the bench. Very good. Please gather the strength, Vishluta. You need to be really strong to break the bench. Please do that. Okay. So my phone broke. Okay. Yes. Hi Anjosh. Everybody, hi Anjosh. Thank you, Alap. Burning furnace. Very good. Look at the next question coming up on your screen. Now this one is not that difficult. Trust me on this. Okay. There is a charge. There is a very large, infinitely large plate. What is the flux passing through that plate? Let's see who is the person who is going to answer this really quick, because it's a one-line answer. This is just a one-line answer. It's just one-line answer. There is a very large plate. What's going to be the flux passing through that large plate? Okay. Very large plate. That's the keyword over here. So you have that charge, and obviously the flux coming out of it, the field lines will look something like this. Yep. And it will go everywhere. Now you have a very large plate like this. What will happen? You will see half of the field lines will eventually cut through it. What is flux? Flux is dependent on number of lines. Flux is directly proportional to the number of field lines. So don't you see, guys, that half of it go through this side eventually. Doesn't matter. Even if you take this one, it will eventually cross it somewhere. Even if you take a line here, eventually it will cross it somewhere. Half of it is going there, half of it is coming here. So the number of flux or the flux passing through that plate is obviously going to be Q by epsilon naught, but into half, because Q by epsilon naught will be the total flux. Q by epsilon naught is basically the total flux. Everybody understood this? It's a one-line answer. Excellent. Not two times, it's half of it. Yes, the total flux will be not 0, Pramesh, it will be Q by epsilon naught. Out of Q by epsilon naught, half of it went here, half of it went here. So Q by epsilon naught into half this side. If there was one more plate here, Q by half epsilon naught on the other side. That's the answer, guys. Okay. Yes, this will come in JEE Mains. And this can also come in NEET. Okay. Chalo, let's get going to the next question. This is also JEE Mains question. A lot of people get scared looking at dielectric. Sir, there is dielectric, sir. Gone, sir. I'm gone.
Okay, so student, in the previous question, सर ने अभी क्या कराया? सर ने कौन से कॉन्सेप्ट्स लिए? That is गॉस लॉ, राइट? अब गॉस लॉ का कॉन्सेप्ट हमें पता होगा तभी तो हम क्या करेंगे, किसी भी क्वेश्चंस में डाल सकेंगे या फिर कोई भी प्रॉब्लम सॉल्व करते गॉस लॉ अप्लाई कर सकते हैं. ठीक है, फॉर्मूला पता होगा, गॉस लॉ का कॉन्सेप्ट एग्जैक्टली होता क्या है, कैसे ये रिलेटेड टू इलेक्ट्रोस्टैटिक्स फ्लक्स के रिलेटेड है. ओके, so let's learn about Gauss law and how to use that Gauss law when we have the some kind of related to question. Okay, so the Gauss law is here. Okay, so in Gauss law, that is somehow related to electric flux. Okay, so अब Gauss law basically क्या कहता है? It has a very formal statement actually, that is Gauss law states that electric flux through any closed surface equal to that is equal to the net charge enclosed by surface divided by the permittivity of vacuum. This is a very formal sentence, okay, and this is the kind of once we learn this concept, this definition, we'll not get to know कि exactly concept क्या कह रहा है, ठीक है. तो मैं यहाँ पे बताती हूँ कि गॉस लॉ में exactly होता क्या है. गॉस लॉ it says that it requires whenever the electric flux which is basically passing through the closed surface, okay, the closed surface, that is again somehow it is related to the flux. So flux equals to Q by epsilon. Can you see here in the definition what it says? The electric flux through only closed surface. So the closed surface, and which is nothing but the equal to the net charge enclosed by the surface, okay. The net charge which is enclosed by the surface, that is nothing but the equal to the electric flux, okay. So we will be having the formula here of Gauss law, that is Q by epsilon naught. Now what is the epsilon naught? Epsilon naught क्या होता है? The epsilon naught is here, that is the permittivity of free space, and it has a constant value, that is 8.85 into 10 raised to minus 12, okay. And we know that what is Q here? The Q, that is the charge which is enclosed in that surface, okay, enclosed charge which is C. And the flux, we already know what is flux. Flux which is nothing but the electric flux, and that's what the Gauss law says. According to the Gauss law, that is electric flux, that is through any closed surface which is equal to the net charge enclosed by the surface. I hope everybody's understood what is exactly Gauss law, right? So what is Gauss law? Phi equals to Q by epsilon naught. And what is epsilon naught? Epsilon naught, it's a permittivity of free space, right? Now let's have a look at another problem, and after that we'll learn the new concept, okay?
Sir, sorry sir, I'm going to skip the question. Guys, trust me, this is such a easy question. There is some dielectric over here, inner radius A, outer radius B. There is a charge Q, okay, there is a charge which is given to the ball. The question is, just outside, what is the field and potential? What is the field and potential? Don't worry about the options. Options will be there in the examination. The logic is very simple. Just use Gauss law. Just use Gauss's law. That's all. What you need to do is just apply Gauss's law on this surface, just outside. So I'll just call this Gaussian surface. Gaussian surface, and this is just outside. This is just outside because we want to find it out, the field and the potential just on the surface. Now if you apply Gauss's law, what am I going to get? Okay, let's try this out. Cyclic integral E dA is, what is the total charge enclosed? Guys, there might be some induced charges, but that doesn't matter, because if there is a plus charge induced, there is an equal amount of negative charge induced. So the total charge inside, irrespective of what is induced or not, will be Q, because induced will be equal amount and they will cancel. So the total charge will be Q by epsilon naught. Bring this E outside, integral of the area and Q by epsilon naught, and there we go. What is the total area? What is the total area, guys? Come on, think about it. The total area will be 4 pi r square. R over here is b square. Q by epsilon naught. So electric field will be 1 upon 4 pi epsilon naught Q by b square. Now guys, this looks to me as if somebody has put a point charge Q and they are asking at a distance b what is the value of electric field and potential. Look at that. This is just like that. So shouldn't one think about using the same logic of finding potential and field for a point charge over here? So if the field is kq by r square, potential would be 1 upon 4 pi epsilon naught q by b. That's the answer. Done, done. Yep. So that's the answer. No, use of dielectrics is just there to confuse you. Often these kind of things come in the examination where people get unnecessarily confused thinking, oh, dielectric, induced charges, they try to find something random. It's not needed. Hello, Unique Gamer, welcome aboard. Did you guys love this question? Did you guys love this method? That's the answer, guys. Shall we go ahead to the next question coming up on your screen? Come on, my warriors. My warriors never give up. Figure it out. Surya, you don't even need that formula. Okay, so unnecessarily finding sigma. You can do it by that formula, Surya, but yeah, we did it very simply using Gauss's law. 2-3 steps, that's it. Okay, chalo, let's get going to the next question coming up on your screen. And there we go. Sanskar, welcome. So guys, first of all, those of you who are joining in new, do not forget to smash the subscribe button and hit the like button, because only then we'll get our strength, we'll get our energy, and this is a free channel for all of you who are preparing for JEE Mains and JEE Advanced 2021. And this is a special English channel. Okay, so you're moving this loop away like this from a current carrying wire. Question is, what's the EMF induced? I'll tell you which formula you might need. I hope you remember I had given you one formula. EMF induced is L dot V cross B. L dot V cross B. This is the formula. Remember this. It's not BLV. A lot of people remember BLV. No, it is L dot V cross B. And the EMF is in the direction of V cross B. Whatever is the direction of velocity cross magnetic field. So that's the direction of the EMF. Let's try this out. So where is the magnetic field? The magnetic field is because of this wire. Use your right hand, place the thumb in the direction of the current. You will see the fingers will curl like this. That means the magnetic field is this way. So you will see that the magnetic field is inside the plane of the board. But remember one thing, it's very strong here and it becomes really weak out there. So it's strong, it becomes weak as you go really far away because the distance changes. Now use the logic L dot V cross B. Where is velocity? It's there. Where is magnetic field? It's inside. So velocity cross B, V cross B, that's upwards. So that means this part is going to behave like an EMF like this. Velocity cross B, V cross B. So it's going to be upwards. Same thing for this part. Velocity is there, magnetic field is inside. So EMF is going to be this way. So this is another EMF. For this part and this part, there will be no EMF. Why? Think about it. Because your V is there, V is there, B is inside, V cross B will come up, but there will be EMF like that, no EMF this way. So there is no EMF across the length, understand that. So that's why no EMF here, okay, no EMF here and no EMF here as well. Is this part understood? No, it is not going to be 0. A lot of people think the answer will be 0. The reason why it is not 0 is because the magnetic field is stronger here. So this EMF will also be stronger. So this is a bigger battery, this is a smaller battery. Why? Because when you are closer to this wire carrying current, the field will be stronger. You can see that. A lot of people make this mistake and write the answer as 0. But anyway, 0 is not even there in the option. So the net EMF will be E1 minus E2. Now what is E? It is LVB, right? L is L only, okay? So I think it's a square side, and V is V only. B is different, okay? What is the value of B? It's mu naught I by 2 pi x1, okay? I'll just call this as x1, minus the second EMF, L, V. The magnetic field there will be again mu naught I by 2 pi x2. Just take out the common terms out here. So we have L, we have V, we have mu naught, we have I, and we also have 2 pi. And if you don't want this 2 pi, you can do one thing. Yep. So we have L, we have V, we have mu naught, we have I. Instead of divided by 2 pi, you can write it divided by 4 pi into 2, because you know the value of mu naught by 4 pi. And this entire thing, 1 by x1 minus 1 by x2. Now it's just a matter of substitution, guys, nothing else, and you will get the answer. So the value of this L, it's given. This side is 10 centimeters, that means it is 0.1 meter. This velocity, that's also given. Well, what's the velocity? It's 10 meters per second. This value, we know, it's nothing but 10 to the power minus 7. This current, that also we know. What's the current going through that? That's 1 ampere. 2, you put it as 2. This x1 is nothing but 10 centimeters. So it is nothing but 0.1 meter. And this x2, that's nothing but 0.2 meters. 0.1 plus 0.1. 10 plus 10, 20 centimeters, which is 0.2 meters. Substitute, you should get the answer. What is it? Yalini says 0.5. Is it really 0.5? Just substitute and see, guys. What are you guys getting? Yep. Sakti, mu naught by 2 pi is nothing but mu naught by 4 pi into 2, which is nothing but 2 into 10 to the power minus 7. Okay. Hello, study VO. Nice to see you. Hi, Arvind Kumar. Good morning. So what is the answer that you are getting? Are you getting it as 0.5 or 1? Be careful, guys. I think you should get it as 1. You can see this 2 is also there. Do not forget that, Pramesh. 2 is also there. Come on, think. Yes, that 2 will get cancelled. Be careful. Answer is C. No. Guys, I'll tell you what. Here is the logic. You don't even have to sit and calculate. Use my trick. Use my trick. What is my trick? Trick is ignore the powers of 10. Just ignore the powers of 10. There is a 2 here. Okay. Now look at this. This is 0.1 minus 1 by 0.1 minus 1 by 0.2. So it is just like, you're going to get a 2 over here. You're going to get 2 into something. This 2 and this 2 will cancel. Rest all are powers of 10. That means the answer must be 1 into something. 10 to the power something. Only numerical values you should take. Yes. So that's the easy way to solve the problem. Okay. So that's answer B. Let's get going to the next question coming up on your screen. Okay.
Okay, so in the previous question, actually, we took a concept of right hand thumbs rule. Okay, right hand thumbs rule लगा के ही हमें पता चला था कि exactly the magnetic field का direction क्या है. Okay, अब किसी concept में अगर कोई right hand thumb rule जैसा कोई concept आ गया तो फिर आप लोग कैसे करोगे? ठीक है, for that you need to understand the right hand thumb rule. Okay, then you will get to know whether that the magnetic field it is going inward or outward, right? So the very simple method we have that we already understood, like from since 9th standard we are learning about that, the very simple concept that is right hand thumb rule. So right hand thumb rule basically कहता क्या है? It says all about that magnetic field का direction किस तरीके किस side हो रहा है. So let's understand here. This rod is basically where the current which is flowing, okay, and because of that current magnetic field which is generating around it, right? अब ये तो हमें इतना सिंपल सा कॉन्सेप्ट तो एवरीबडी नोज दैट कि जहां भी करंट फ्लो होता है उसके अराउंड मैग्नेटिक फील्ड क्रिएट होता है. ओके, but that magnetic field is created, but in which direction the magnetic field, what is the direction of magnetic field? So that we'll get to know from this right hand thumb rule. Okay, so right hand thumb rule, that means अपना right hand लेना है and this is the the thumb rule. So basically our thumb, it will show the direction of current, like here it will show the direction of current. Okay, the direction of current this way. Once again, okay, this is the direction of current, as you can see in a picture that is showing, that is the I. So that means the current, you know, the basic, this thumb basically showing the right hand, the direction of current. The curl finger basically, this curl finger shows around this rod the magnetic field which is created. So when we do this, so as you can see, the current basically which is, you know, moving, you know, if I'll take now, it is going inward. So in this case, basically, magnetic field, the direction of magnetic field which is inward, right? Which is inward. But the same way, let's say the direction of current this way, okay, this way, okay. Now this is my current, the direction of current this way, and the magnetic field which is generated around it, okay. Now as you can see, the current coming out, this arrow, the current which is coming out, correct? So what does mean it? So that means the direction of current which is outward, right? So the direction of current in this case, that is outward, okay. So यहाँ से हमें पता exactly कहाँ चल जाएगा, जब हमें right hand thumb rule पता मतलब लगाना आएगा basically, then we will get to know कि exactly the magnetic field का direction क्या है, ठीक है? Either it is inward or outward, okay. So right hand thumb rule अच्छे से पढ़ लेना, like any question which comes based on it, you can simply find out, okay. So let's take another question, then after we'll learn more concepts, okay.
Come on, my warriors, figure this out. Okay, so two coaxial solenoids are made by winding thin insulated wire over a pipe of cross-sectional area so and so, length so and so. If one of the solenoid has this many turns, other has this many turns, what's their mutual inductance? Yes. So my point is, if you remember the formula for mutual inductance, this question will look very, very easy for you. What's the formula for mutual inductance? Now that's the question. So M, how many of you remember it? Let's see how many of you remember it. What was the formula for M, guys? Mutual inductance. It was mu naught, try and recollect, N1, number of turns in solenoid 1 into number of turns into solenoid 2, and also there was area over there, I hope you remember, and the whole thing divided by length L. This was the formula. Now you should remember it, and rest everything is simple. Mu naught is nothing but 4 pi into 10 to the power minus 7. What is N1? N1 is 300, other N2 is 400. So that's going to be 300 into 400 into area. Well, area is 10 centimeters square. So 10 into 10 to the power minus 4. The whole thing divided by the length, which is 20 centimeter, which is nothing but 0.2. Yep. Now do this math, you'll get the answer. Yep. Okay, come on, my warriors. What is the final answer? Pi, I think, will be there in the answer. Just check this out. Just do the simple math. 4 3s are 12. 4 is there here. 2 is there here. 4 divided by 2 is 2. Come on, guys. You should be able to get it. So don't worry about the powers of 10 again. I'm telling you this. Just don't worry about the powers of 10. Hi, Aditya. Thank you. So 4 into 3, 12. 12 into 4, 48. 48 divided by 2, 24. So 24 will be there in the answer. But 24 is there here also. But there is a pi. And remember, we did not calculate pi here. So hence, this answer would be the correct one. Yep. Remember, these are the simple techniques which you should use for calculation in the examination. Ignoring the powers of 10. I have been telling, oops, this was supposed to be D option. Okay. I think the answer marked over here is wrong. My God, that was a blunder, guys. Okay, I'm just going to change it so that you guys get the correct answer. Yeah. So the correct answer is D, 2.4 pi into 10 to the power minus 4. Yep. Okay, very good Pramesh, very good Surya, very good Sakti, very good Shruti, very good Chitti, very good everyone, Ankush, Anees, very good. Arya, yep. Now, let's get going to the next question.
Okay, so in the latest question, student, we have used the concept of this one. Once again, so we use the concept of inductance, right? So in the inductance part, basically, like the inductance we used, but for the understanding the part of inductance, we first of all we need to understand what is exactly the concept of it. Okay, so let me tell you exactly the concept of the inductance. So inductance basically it is nothing but the production of current in the coil due to change in magnetic flux. Okay, the very first, okay, it's it's everything is correlated. Change in magnetic field. Induction, what does mean of induction? Induction, that means the production of current in coil. In any of the coil, the production of current due to change in magnetic field, magnetic flux. And the magnetic flux is generated due to change in current. Okay, change in current, that means magnetic flux is generated. Change in magnetic flux, that means current is generating in some of the coil, and that's what we call the inductance. Okay, so inductance here basically, so inductance have the formula, basically the inductance we are symbolizing with the L, that we all know, right? And we have a formula that is L equals to phi I by I. Okay, so this is nothing but the inductance part. And in the previous, the latest question only, the Shreyas Sir has used the self-inductance and the mutual inductance wala concept, right? So we have two types of inductance. Basically, the production of current in the coil due to magnetic, due to change in magnetic flux, that's been divided into two parts. The very first is self-inductance and the second is mutual inductance. Now you will be asking me what is the difference, what exactly even the name says self, that means self-inductance. If somebody, it's like, the very simple example we can take here, like तुमने खुद ही study किया and you scored good marks. Okay, that means खुद ही पढ़ाई अच्छे से करी और खुद ही अच्छा स्कोर लेकर आए. But when we come to the mutual inductance, let's say कि तुम्हारे friend ने अच्छी study करी, okay, and you got the good score. You didn't do anything. Okay, so that means because of someone doing something, okay, and you got the, so इसका मतलब basically what I am trying to say here, in self inductance basically change in flux in the same, coil, and same coil gets, production of current. But when it comes to, mutual inductance, there are, two coils, the coaxial coils are fitted. Let's learn a bit more about it. Okay, so basically here what happens, in a mutual inductance, let's say हमने इस तरीके से एक कॉइल ले लिया जिसका नाम लिख दिया C1, okay, and inside there is one more coil, and it is C2. Okay, due to change in flux, C2, the C1 gets current, the C1 get induced. Okay, so that's what we call the mutual inductance. That's what we call the mutual inductance part. Okay, so self-inductance that means the same coil which gets, induced after changing magnetic flux. Okay, as you can see here, the same coil, if we will be giving a, current in it, because of that there will be change in flux, change in magnetic flux, right? And that entire coil, it will get, induced. So for that we have a formula that is L equals to mu r mu naught n square A into L. Now you will be asking what is mu naught? Mu naught we understood, that is permittivity, right? But that N is what? N is nothing but the number of turns per unit length. Not only number of turns, okay? Number of turns per unit length, right? Okay, and we know that the A, it is a cross-sectional area. Okay, L is a length of the coil, and now here the mu r. What is the mu r? Just let's consider, if just let's try to imagine in this coil, if we are putting some kind of solid material or some kind of medium which gives the dielectric medium. So that is basically the relative permittivity we are putting. So that is why we are putting here mu r. So this is about the self-inductance part. Okay. Now let's learn a bit more about the mutual inductance. Okay. So mutual inductance also we have learned, that is when two coils, basically the coaxial coil, they are overlapped. Okay. Let's say one coil inside and outer coil is here. So they have the coaxial coils, right? So because in mutual inductance, that means if the one coil get if in one coil the magnetic flux get changed, okay, magnetic flux is getting changed in first coil, okay, because of that the second coil get induced. Because of that the second coil gets induced. So that is that exactly we call the mutual inductance. So we have a formula here for the mutual inductance, that is M, okay, mutual, that means M, and mu r, M equals to mu r mu naught N1 N2, that is number of turns per unit length for the first coil and the number of turns per unit length for the second coil, and the R, it's a radius, and R square, R1 square and L. Okay, so this is the formula for the mutual inductance. So I hope you understood that is the concept of inductance, self-inductance and mutual inductance. Okay, so let's take few more problem, and then we'll after learn few more concepts. Okay.
Question: a fully charged capacitor has a capacitance C. It is discharged to a small coil of resistance wire embedded in a thermally insulated block of some heat capacity and some mass. If the temperature increases by some amount, what is the potential difference across the capacitor? Two things combined together, two chapters combined together. Let's see how do we do this. Understand what is given in the question. This was asked in JEE 2005. Like I said, I am giving PYQ as well. The capacitor is charged. That means it has some energy. When you discharge that, the current will flow through the resistance. And once it flows through the resistance, what will happen? Heat will be developed. And what will that heat be used for? It will be used to change the temperature. So my first statement would be the energy stored in that capacitor gets discharged via that resistance. Okay, it gets discharged via that resistance, and eventually that heats the mass and it increases the temperature by delta T. That's the logic. So what's the energy stored in the capacitor? That's half CV square. What's the formula for heat supplied and temperature change in thermodynamics? You have seen that MS delta T. So naturally voltage square will be 2 MS delta T divided by C. But that's V square. I want only V. So which will be the correct answer? Okay, just think about it. Just think about it. Heat capacity S. So I think the answer should be C, right? Yep. The answer should be C. Correct. So that's the answer, guys. 2 ms delta T by C. Correcto. Beautiful. Option C. Excellent. Let's get going to the next question coming up on your screen. Amazing question. A positive point charge is released from rest at some distance from a line charge. This is the line charge. From that line charge at a distance, you are releasing a point charge. What is the speed as a function of that distance? What is the speed as a function of that distance? Now this is very interesting. I'll tell you what, there is a very easy way to do this. Don't complicate. I'll tell you what to do. See guys, the question is to find speed as a function of distance. Whenever you have speed, okay, and distance, the first thing that should come to your mind is work kinetic energy theorem. Work done goes in changing the energy because there is no time in that. So the logic over here is the work done by electric force. The work done by electric force goes into changing the kinetic energy. Fair enough, the work done goes directly into changing the kinetic energy. Now what is the final kinetic energy? Well, that's half mv square. What is the initial kinetic energy? A point charge is released. That means initial velocity is 0. So initial kinetic energy is also 0. Now work done will be work done by a variable force, F dr. Why is this force variable? Because the field is variable. I don't know if you remember this, but for a line charge, which is charged like this, the field is variable. The field is variable. In fact, you remember that formula, it was 1 upon 2 pi epsilon naught lambda by r. If you remember that formula. So basically, the thing is, it is inversely proportional to r. These are all constants. Just forget that. It's just some constant divided by r. Just remember this. It's inversely proportional to r. That's it. So basically, what you need to do is that just use that field formula over here. So it's some constant by r into charge. Okay, even the charge is some constant, don't worry about it, into dr. This is equal to half mv square. Did you guys understand this, what I just did? This is field into charge is force dot dr. That's all I did. Now put the limits, r naught r. Okay, C and Q will come outside. So C and Q are outside. dr by r is ln r. So ln r from the limits r naught to r. And this is equal to half mv square. Well, this CQ and all these things are constants anyways. So this will be ln r by r naught is equal to m by 2 CQ, and you have v square. So don't you see v square is directly proportional to log of r by r naught. That means velocity is proportional to root of log of r by r naught. Option B, correct. I hope this is clear. Understood? Very good, Shruti. Very good, Pramesh. Very good, Aryan. Excellent. This was such a beautiful question. You don't have to complicate it so much. Solve it by work kinetic energy theorem. That's it. Okay. Cool. Let's get going. Come on. Now, before going ahead, remember in our crash courses, the platform used is wave platform, and that will inculcate a lot of amazing features like animations, chat boxes, chatting with our second teacher who is called as the class teacher for all your doubts, and quizzes along with leaderboards so that you feel you are in the competition. Every class has this, and you can see the teacher here. This is a special platform where you can chat. The chat is moderated very effectively, and also you have the Q&A box for getting all your doubts answered in the live class. So that's the benefit that you get. So let's get going to the next question coming up on your screen. Are you guys full of Josh? Let me know.
Okay. So in the previous, the question, in the doubt, the sir has used the concept that is work energy theorem. Okay, that question, it was completely based on work energy theorem, right? So now let's learn what exactly work energy theorem. Okay, if we will know that, if we are more clear about what exactly work energy theorem, then obviously we will be able to apply that, concept in any of the problem. Okay, so let's learn bit more about it. So here the work energy theorem, the very formal statement here, you can check, you can see here, the total work done by the sum of all the forces acting on a particle is equal to the change in kinetic energy. What does mean it basically? Okay, what does mean it here? So what, according to this basically, what the definition is saying, total work done by all the forces. Okay, so work done, we all know the work done we are symbolizing with the W. Total work done, let me write that is delta W. Okay, that work done by all the forces, all the conservative force, non-conservative force, friction force, gravitational force. That means all the forces, the meaning of this, all the forces, the work done by all the forces on particular particle, that is equal to change in kinetic energy. Okay, change in kinetic energy. So simply let me modify this, equation only. So work done by all the forces, here we can write all the forces, okay, equals to change in kinetic energy. Okay, now how it came basically, okay, that we need to understand how this basically, this formula came. Okay, so let's understand here basically. So we know that, variable force. Okay, variable force, that we know that basically, let's say here, this is the our, the f of x, graph, and this particular, the curve which shows basically the work done by that particular force. Okay, so that means we can write that is, work done by equals to f x dx. Okay, since if we are taking very small, let me just, divide into very small part here. So if I am taking this much particular part of this graph, so here will, when we are calculating, जब हम क्या करते हैं, कुछ calculate करते हैं बहुत small quantity में, then that time we apply integration, right? So that means work done equals to integration of fx dot dx. And we also know that what is f? F is mass into acceleration. So when we are putting the mass into acceleration, so let's simply, we can put here integration of ma dot dx. Now the m is constant here. Okay, this a can be written as dv by dt. Okay, dv by dt, and this dx, let's write as it is. Okay, now this a can also be write this way, that is v dx by, dt and, dt. Okay, so this way we can write. Okay, so at the place of this we can write omega, not omega, work done equals to integration of that is v square, m is as it is, and this, dt. Okay, so now if we will take this integration will go I to final, initial to final. So that means it will go like this, that is the m will be as it is, that is v square by 2 initial to final one, right? So initial to final one we will be putting, so we'll be getting that is half m vi the whole square minus final, okay, and that half m vi square, this way. So here again we got the value, that is omega, that work done equals to half mv square, the change in kinetic energy. So that's what the work energy theorem is saying here, okay. So what is the work energy theorem? Basically the work energy theorem, that is the total work done by the sum of all the forces acting on the particle is change in kinetic energy. So simply you just need to understand that is change in, work done by the all the forces, change in kinetic energy, okay, that we need to understand, okay. So this is about the work energy theorem. Going forward we are going to take a few more questions, so let's have a look on that question as well.
Yeah. Shall we go ahead with the next question? Let me know by putting some fire in the chat box. ऐसा लग रहा है I'm teaching zombies. Come on, put some fire. Build up, gather up your strength, guys. Already Pramesh has answered the question. Come on. Yo, very good. Come on. Always perpendicular. Okay. Very interesting question. A closed loop lying in the xy plane carries some current. A uniform field is present in the region. The force acting on the loop will be 0 if... Very, very simple. Think about it. Hello Devansh, welcome aboard. Guys, the answer is, well, a closed loop, right? The force acting on a loop is always 0 in uniform field. In uniform field, no matter how the orientation is, for all orientations, always, they will always cancel. But torque may be 0 or may not be 0. Remember, I have told you this. In fact, the value of the torque is m cross b. But force is always 0 in uniform field. So hence, the answer is for all the above options. So answer is D. Yep. How this is killer. Yep. Okay. Chalo, let's get going to the next question coming up on your screen. A lot of you made a mistake out there. A lot of you thought the answer was C. Okay. So the next question is coming up on your screen, and here it is. A horizontal straight conductor of mass m and length L is placed in uniform vertical field. Okay. An amount of charge which needs to be passed through the rod in very short time, so that the conductor begins to move only when the charge has passed is, okay, so think about it. What will be the velocity? Okay, come on, my warriors. Oh, so much of twist. Yes, Sakti, lot of twist. What to do? Okay, come on, my warriors. Think about it. Well. What formula should we use? I did a mistake. Happens, Pramesh. Here is the thing. There is a rod. Okay. And in that rod of length L and certain mass, there will be some current which will pass. That current which will be charge which flows divided by the time. Charge by the time. Okay. Next up, whenever current flows, what will happen? There will be a force in it because of the magnetic field, and that force will be ILB force. IL cross B, that's the force acting on it. Now, whenever there is a force for a small time, why a force for a small time? Because this current will flow only for a small time, because the charge will go only for a small time. The charge goes for a very short time. So current is for a short time, force is for a short time. It will create impulse. And what is impulse? It's change in momentum. Just use this fact now. So force for a small time creates impulse. So force into time actually gives you impulse. Force delta T is impulse, remember that. So time multiplied by that force is final momentum minus initial momentum. Everybody getting this? Okay. Now let's just put this as it is. What is the value of the force? Oh, the force is ILB. That's going to be MV. Oh, but wait a minute. I into T, you can see that I into T is Q. So I into T is nothing but Q. LB is equal to MV. Now what was the question? The question was the velocity. Yes, so the velocity will be QLB by M. So the answer is option C. Just check this out. Yep. Okay. Sudhanshu, please watch my lecture from the start. At the start, मैंने एक timetable दिया है. I've given a timetable, and on the Thursday, I'm doing a marathon session right from units and dimensions, vectors, and then 1D kinematics. So a marathon session for 5+ hours. Plus, all my lectures of 1D kinematics are there in the playlist. Go ahead, just search for it. You will get the 1D kinematics playlist. Okay. Chalo. Let's get going to the next one. Okay. Beautiful question coming up on your screen again. Well, here we go. Here we go. A conductor AB of certain length is placed and there is a current carrying I in it, and it is perpendicular to a long wire which itself is carrying current. The force on AB will act in which direction? Achha. So there is a long wire and there is a short wire. This wire is carrying current. This wire is also carrying current. The force due to the field by this long wire on the short wire will do what? Think about it. Think about it. Come on, come on, come on, my warriors. Come on, my warriors, think about it. What will be the final answer? Okay, right hand thumb rule. Yep, use the right hand thumb rule. Very good. And first thing, because of this wire which carries current, how will the field be? The field will be, use your right hand, the field will be like this. So the field will be in fact inside the plane of the board. Okay, this will be inside the plane of the board. Now the force is IL cross B. B, remember, is inside. Okay, length is that way, it's this way for that rod. So L cross B, L cross B, where is the force coming out to be? This force will come out to be upwards. Just check this out. Is the force coming out to be upward? Yep, very good, excellent. So hence the answer is option A, which is upwards. So tricky question, you just need to use right hand rule, you need to know your formulas, you need to use your fingers properly of your right hand, that's it, and you're going to get the answer. Next question is also very interesting. Let's see how many of you can do this. Thank you, Sudhanshu. Okay, but don't spam bacha so much because the admin will block. Okay, chalo. Saran says A already, 0. Be careful. I think you were mentioning the previous question. Okay, let's see. There is a semicircular wire and it is falling down with velocity V. It's falling down with velocity V. So the question is, what is the EMF and which one is at higher potential? Now I don't know whether you know this rule, but if you have a curved wire, you can always replace it with a straight wire. You can replace it, and the EMF generated in this is the same as the EMF generated in a straight wire, which is LV cross B. Yep, that's the EMF generated. You can replace it with a straight wire. Keep this in mind. So over here, let's replace the semicircular wire with a straight wire. So what will be the length obviously the length will be the diameter, which is 2 times the radius. So what would be the EMF? Well, it will be L V into B. What is B? B is B. Yes, that's the answer. So where is it? 2R BV. Yes, all these options are wrong. Option D will be correct. And which one is at higher potential? Well, I have told you the direction of EMF is always, remember, V cross B. So velocity is down, B is there. So you're going to see that EMF will be like this. You can do that. V cross B. Velocity is down, B is inside. You will see your thumb going towards your right side. So that means this is higher, this is lower, plus minus. So Q is at a higher potential than of M. That's how you do it. Get the direction. Okay, so the answer is D. Let's get moving to the next question coming up on your screen. Amazing questions, guys, coming up for all of you. And I'm loving the interaction. I'm loving the way you guys are waking up in the morning, all geared up. Trust me, guys, just because you're attending the classes, just because, even on YouTube, forget the crash course or anything, even just because of this YouTube, you are one notch higher than the rest of the crowd who is sleeping. Like, the exam dates are not out, let me not study. When the exam dates are out, when Ramesh Pokhriyal sir is going to come, that's the auspicious day, I'm going to sit and study. Those guys are losers. Those guys are not going to make it. Trust me on this. Because you guys are in the mood. To get into the mood takes a long time. Most of the people who have given up or waiting for the dates have lost it. They will take a long time to even get into the mode of studies. So trust me, you're already a notch higher. Now the last few days you need that preparation, that push. Yes, for that you can join the crash course and get those mock tests, the discussions, the assignments and all of that. And I'm pretty sure the date is around the corner. It's just a matter of time when the date will be announced. Don't worry. Oh yeah, one day we need to have that early morning class. Guys, I'm thinking just on the last week of exam, how about this night studies one day? More early morning, like 3 o'clock or 4 o'clock. Let's wake up and we'll call it Jagran or something, and we'll have some very cool class right from the morning. It will be fun, guys. Trust me on that. It will be epic fun. I am very excited for this. Thank you for all these creative ideas you guys come up with here. Okay, let's do this. Okay. Yes. Okay, yeah. Look at all you people. You're, mu naught I by 2 pi something x. Okay, the distance, whatever is there. Okay. Now, what we have, okay, this x is also given, that is nothing but d. The force on the loop by the field of the wire, the straight wire, can be magnitude wise written down as del u by del r. Del u by del r. Think about it. F is du by dx, and this u is nothing but, think about it, is the potential energy of this loop because of the field of this wire. M dot B, I hope you remember, it was MB, magnetic moment into field. U is nothing but MB. Now, which of the two is constant? Think about that. Okay, which of the two is constant? Well, I think M is constant. B might change with distance. So just bring that, M outside and just write it as dB by dr. Okay. Now, actually, let me make this as a variable. That will be very convenient to solve this. Now, dV by dr means the rate of change of field with respect to r, and magnetic moment will be Ni into area. Okay, Ni into area, and dV by dr will be mu naught I by 2 pi derivative of 1 by r. So d by dr of 1 by r means r raised to minus 1. This is what we are going to get. Most of the things are constants, so just write down constants. Okay, don't worry about it. Area of that loop. What is the radius of the loop? The radius of the loop is small a. So it is nothing but going to be pi a square, okay, into, all these are constants, derivative of r raised to minus 1 will be r raised to minus 2, and that minus 1 will come outside. So r raised to minus 2, that minus will come outside, don't worry about it. So again it will be some constants into a square by r square. So a square by r square, where is it? This one, because this d exactly is this r. That's it. That's how you solve this question. So the trick is to find force using this formula du by dr. U is mb, magnetic field into magnetic moment, the dot product is potential energy of any loop, remember that. Now m was a constant because the loop area is constant, current area is also constant, just bring it out. dB by dr, this magnetic field was because of this wire's field over here. So this was the external field for this loop. That was the whole point for solving the question. Definitely Pramesh, I would love to meet all of you. You like the sound, the constants? Yeah, it's so convenient, right? A lot of people, you know what they do? They waste their time writing those constants. It's a waste of time in the exam. Don't worry about constants. If you see there is proportionality in the question. So what you need to do is just forget it. Just get rid of it. Just write constants or C or K or whatever. And just worry about what has been asked. Look at what has been asked. And based on that, you write down the proportionalities. Only the relevant terms should be there in the solution. Okay, one good question coming up for all of you, and there we go. There is a charge fixed at the origin. There is a dipole which is here, and it is pointing away from the x-axis, okay, from the origin rather, and it is free to move and rotate. So this is a fixed charge. This is free to rotate, free to move. It can do anything that it wants in free space. If it is completely set free, what do you think the dipole will do? Who is it? Very nice, Pravesh. Hello, Umesh. Welcome aboard. And hi, Potan. Welcome aboard. Arya. Yep, definitely, Arya. We are just waiting for that final announcement by Ramesh Pokhriyal sir, definitely. And the thing, Arya, I'll tell you one important thing. I know you want a specific NEET class, I will do that. But trust me guys, even when you attend the JEE classes, your knowledge will improve. Because I know what NEET students, most of them they are doing, they're just attending the NEET classes. Fine, good. Obviously, you're going to benefit from that. But if you attend JEE classes, you're going to go one notch higher. And when good questions come, and when you see those techniques which we use in JEE, trust me, it is going to be very helpful for you for all those difficult, the above average questions in NEET examination. But for all those standard questions and the typical type of questions, don't worry, we'll conduct a session for NEET students also very soon on catalysis. Okay? Okay. Chalo, let's see. Yeah, Yalini, I know that you're a NEET student but full time for JEE. Okay. Chalo, let's do this. What is going to happen? This is a charge. Obviously, it will create a field like this. This charge is going to create, wow, looks like sun rays. Guys, this reminds me how those days were when you were in second standard. You used to draw these rays when, used to draw those drawings for the sunrise and that mountains. And then you just had to use some color pencils, draw brown color, yellow color, that sky, and just show some birds. And then a person walking on the down the river and just get some marks out there, and that's it. That's my exam, and yeah, you just go out. Yeah, chill. My exam is done, and look at what we are doing now, you know. So, okay, cool. Let's do this. And where are we? Yeah. So this dipole will get some field. Oh, we know this. Now what to do? Torque is P cross E. Torque is P cross E. Missing that life. So P cross E. P is there. Look at that. P cross E will be 0. Theta. Theta is 0. So torque will be 0. So for sure it won't rotate. So rotate is not an option. Force, yes, it is an option. Look at that. The negative charge is closer to the positive charge. So the force of attraction compared to the force of repulsion, obviously the attractive force will be more than the force of repulsion.
I hope everybody's enjoyed this session. So in this session, we have solved a few questions, which was NEET based question, and also JEE main concept questions was there. Okay. So I hope like everybody got to know how to solve the question using the concepts and all. So let's meet in the other sessions as well. Okay. Bye bye everyone. Take care.